right, welcome. This is the beginning of chapter 20, and we are now beginning really the essence of second semester. This is hypothesis testing, and it's something that we'll do over and over and over again for means, for one samples, for two samples. So it's important we get a good foundation. I really wish I could be there today with you because I know this is really one of those lessons that just seems overwhelmingly difficult. And then somewhere in the middle of second semester, you're going to look at me and say, oh, this is just like the last one and the last one and the last one. But you got to start somewhere. So today we're starting on chapter 20. So the first thing you want to know is that the null hypothesis is the claim that's being assessed. We call it the HO, H-O. And the alternative hypothesis is something that proposes we're going to reject the null because it's no longer a likely hypothesis. We call that the HA. So we have the HO and the HA. There are two-sided alternative hypotheses that say the HA, where P is not equal to P naught. That's when we're interested in a deviation in either direction. It could be more, it could be less. A one-sided hypothesis usually has a greater than or a less than symbol, where you say what we believe is less than what is standard accepted or more than. And your p-value, which is really important in statistics, is the probability of observing a value for a test statistic at least as far from the hypothesized value as the statistic value actually observed, if the null is true. So in other words, when you get a really small p-value, it means that you have an improbable null hypothesis. So we would probably reject the null. What we like to say is if the P is low, reject the HO. And at this point, everybody's giggling, but we will learn that when you have a very small p-value, you're going to reject the null hypothesis. Okay, what we need to do is find the z-score, and that's going to be your p hat minus your null hypothesis value over the standard deviation of p hat. Okay, so let me go through the first example. Oh, statistically significant is when you have a very low p-value. It means that we found evidence to the contrary of what we believe in the null hypothesis. Okay, so we are going to practice writing hypothesis tests. So is a coin fair? So the HO is the probability of getting heads or tails is 1/2. Now, because we don't know which one we're worried about, we just say it's not going to be equal to 1/2. And that's a two-sided hypothesis. The not equal to means it could be on either tail. Only 34% of people who try to quit smoking succeed. A company claims that using their chewing gum can help people quit. So if 34% is what we believe succeed, then we want their rate to be greater than 34. And the greater than symbol is always in the higher tail. This one says in the 50s, only about 40% of high school graduates went on to college. Has that percentage changed? So you say, okay, 40% was what we believed went to high school, and we're saying it's not equal to 40. We don't know if it's greater than or less than, so it's a two-tailed hypothesis. A large city's DMV claimed that 80% of candidates pass driving tests, but a newspaper reporter claims this rate is lower. So we're going to say the null hypothesis is P is 80% or 0.8, and the reporter's claim is that it's less than 0.8. So now you're in a lower tail. Okay, I'm going to let you read these in the notes. I'm not going to read them all to you. Okay, so what we're going to do is use phantoms for our hypothesis until we get used to the idea. This way we don't leave any steps out. It's really important you understand. The P stands for the parameter of interest. State in a single sentence what you're trying to prove. The H stands for both the null and the alternative hypotheses, the HO and the HA. The assumptions, you're going to have 4 assumptions and conditions. We're going to work off proportions, assumptions, and conditions. And you're going to have either a 1 prop or a 2 prop test based on how many tails you have. A 1 prop is using a greater than or less than symbol. A 2 prop is using the not equal to symbol. And then we're going to find the z-score, find the p-value using the z-score, and then reject or fail to reject the null. Okay, so the first practice problem says in 1996, a U.S. Consumer Product Safety Commission claimed 90% of all American homes had at least one smoke detector. And some cities' fire department has been running a public safety campaign about smoke detectors, and they've used posters, billboards, ads on TV and radio. and the newspaper. And they wonder if this effort has raised the local level above the 90%. That's important to know which hoe and haw to use. So what they did is they took a random sample of 400 selected homes and found 376 did have smoke detectors. Now they're asking, is this evidence? Is it statistically significant that the rate is higher than the national rate? So your parameter of interest is this: do more than 90% of the homes in the city have smoke detectors? Okay, a single sentence. That's what we're looking at. Your hoe and your haw. Well, you know your hoe is going to be 0.90, p equals 0.90. It's got to be a number between 0 and 1. And they're saying it's greater than 0.90 in this city, so that's the haw. Now, at this point, I want to take a few numbers that we need. So your P naught is going to be 0.9 when we use our calculations, and your Q naught will have to be 0.1. Your P hat is your actual sample values. We got 376 out of 400, so that's 0.94. I know there's a bunch of P's in this, but it's important you know which one is the hypothesis, the null hypothesis, and which one is the actual sample. And of course, our N, our sample size is 400. So for those assumptions and conditions, is it random? Yes, they stated. Is it independent? Yeah, you can assume that one person's home isn't going to depend on another person's smoke detector in their home. The 10% condition is 400 less than 10% of all homes in this city. Most cities have more than 4,000 residents, so what we would say that's reasonable to assume. And then the last one is your NP and Q. So NP is the successes, and we had 376 successes, and those are greater than 10. So NQ are the failures. There's only 24 homes out of the 400 who didn't, and that's also greater than or equal to 10. So we're good to go. So they want you to name the test. The name of this test is going to be a one prop Z test. Okay. One tail only because we're using one proportion. That's the 376 over 400. And we're only checking the greater than condition. So that's one tail. So now you have to run your test statistic. First, we're going to find the standard deviation of the sample. But in hypothesis testing, we do not use p hats and q hats. We must use the null hypothesis. So that's going to be 0.9 and 0.1 over 400. So the standard deviation for this sampling statistic is 0.015. The z-score is the p hat minus p naught over the standard deviation. Well, you know your p hat was 0.94, and you know your p naught was 0.9, and we just found the standard deviation to be 0.015. So when you put that in the calculator, you get a z-score of 2.67, which is more than 2 standard deviations from the mean. So that's unusual. Is it statistically significant? Well, let's find the p-value. So my calculator doesn't work, but you have to go to normal CDF and use your lower bound of the z-score 2.67. Your upper bound will be 999 because we always go to infinity, but they don't have a button. And your mean for a z-score is 0 and your standard deviation is 1. So what we got was a p-value of 0.0038, okay? That is less than 0.05, which we are going to use for the first few days. We're going to say 0.05 is an unusual number if it's less than that, and that is less. So your decision is if the p is low, reject the hoe. So we are going to reject the null hypothesis. Okay, and then they always want you to write your conclusion in context. So here's a little picture of what I did for the normal distribution. You're going to go to second vars, normal CDF, and put these numbers in. Okay, so these are the words I want you to use. Based on you'll either say low or high. We got a low p-value, and then you're going to report what it is, 0.0038. If it's low, we reject. If it's high, we fail to reject the null and say there is for low, is not is for high. There is evidence to suggest that more than 90% of the homes in the city have smoke detectors. Now, I do need you to do these by hand, but in the TI-84, you can go to stat tests, one prop Z test. I believe that's 0, selection item 0. And you're going to add a P naught of 0.9, an X of 376, an N of 400, and you're going to choose the greater than symbol because that was in your hoe. And your output will be that we got a z-score of 2.6 repeating. Your p-value is 0.0038304. Your p-hat was this and that. So now you know that you had the 0.0038 and it was a sanity check to use at the TI-84, so that was correct. Oh, let me do this. Okay, and now what we're going to do is a 95% confidence interval. You just did those last class. So remember that's p hat plus or minus your z critical times the square root of p hat q hat over n. So we're doing a 95% confidence interval, which means our alpha level, our significance level we compared our p-value to is 0.05. These two should add up to 1. And that is a 1.96 for your z critical, if you'll recall from last class. So we're going to do this calculation, and what I got was my confidence interval was from 0.916 to 0.963. Now, notice they said this city has greater than 90%. All of the numbers in this confidence interval are greater than 90%. So that's just another sanity check. We are 95% confident that the true proportion of homes in this city with at least one smoke detector is in the interval of 91.7 to 96.3. And since 90 is not in that interval, we are fairly certain that that is correct.